And okay, let's get started. Okay, number one, on your own, you need to combine like terms. Okay, if you have any questions about that, some of you had really strong Algebra 1 courses last year, and some of you have a few gaps that we need to work on filling in. Okay, number one is on your own. Number two. Okay, let's solve this equation. Any suggestions for step one? Let's look at the left side. Looks pretty clean. Let's look at the right side. Does not look clean. It looks like there's something we can do on the right. All right, thank you. Combine like terms. So with your calculator, everybody practice -4 take away 4, or keep change, -4 plus -4. We need to know how to do that on the calculator. So -4 take away 4 is how much? Yeah, anyone feeling brave? Ding, ding, ding. Thank you. -8a minus 2. Okay, so that was combine like terms. Now we're going to isolate our variable. So we need to pick a side. So we're going to have the variables go to one side and the constant terms, the terms that don't have a variable, go to the other side. Okay, so I'm going to pick this as the king of the equation right here. That is the most powerful term. You could pick the -8a, but I'm going to pick my positive variable. It's also on the left. I like it when it's off on the left. So the 2a is the king of this equation. So I want all the variables to the left, all of the constant terms to the right. What should I do next? There's two possible correct answers. If you're thinking, well, I don't know if she wants to do this first or this first, either one. So we are isolating the variable. We are not combining any like terms, isolating the variable. What am I going to do next? Let's move one of the terms. Okay, the 2a, all right, thank you. So I want to get rid of the -8a, so I'm going to add 8a. Okay, so now I have no more a's on the right side because I want all my a's to the left and all my constant terms to the right. So I have 8 plus 10a is equal to -2. Okay, notice how the equation started off really long and complicated and is getting more and more, it's getting smaller and smaller, more condensed. So who needs to move next?
The 8.
All right, thank you. So we're going to subtract 8 from both sides. So 10a is equal to -8. Now notice empty space between the 10 and the a. The empty space in algebra means multiplication. If there is nothing between the number and the variable, it's, oh, there's a typo. Anyone see my typo? Told you my brain's a little frazzled this morning. Anyone see anything you want to correct? That's a -10, right? Not -8. Yeah? You're like, I don't really like typing. Okay, now let's do it. So the 10 is being multiplied. How do you know it's multiplied? There's a blank space, baby. I'll write your name. I'll write multiply. Okay, so how do we get rid of 10 multiplied by A? What do we do to both sides? Yeah?
Divide.
All right, we're going to divide by 10. Thank you. Yeah, so A is equal to -1. Okay, so I want you to go. Some of you don't want to take advanced algebra, but if you are taking advanced algebra, I want you to go in strong in your ability to solve equations. Okay, let's talk about dilation. Dilation is when you see the shapes nest. Okay, they're basically going to have the same center and they're going to nest. So what I'm going to do is I'm going to take G, which is, what is G? 2, 3. And I should have done this first. F is -2, 0. And H is 2, -2. Okay, so in a dilation, they are similar figures, okay? Nested together, like the little dolls from old school Russia. Anyway, the little nesting dolls. So what I need to do is I need to multiply both terms by 1.5. So if I multiply by 1.5, right? If I multiply by a number, any number greater than 1, is my new figure going to be bigger or smaller if I multiply by 1.5? Anyone have a guess? Yeah, bigger or smaller? Ding, ding, ding. It's actually going to be bigger. So G prime is the new set of coordinates. 2 times 1.5 is 3. 3 times 1.5 is 4.5. F prime, my new set of coordinates, is -3. 0 times 1.5 is 0. H prime is +3, -3. Okay, so now we're going to graph the new sets of coordinates. So 3, 4.5 is G prime, -3, 0, F prime, and 3, -3. And look how nicely that nests. Sorry, my lines are not very straight. Okay, and okay, so there it is, a dilation of 1.5. So these were the old and these were the new. And the rule was 1.5. So I took the old coordinates, I multiplied by 1.5 to get the new coordinates. Or you could see that new divided by old would give me 1.5. Okay, number 4, write a rule to describe the transformation. Now, this is a lot better in color, but you know the new ones have the prime. Yeah, and I learned from above that, let's just peek. Okay, new divided by old will give me the rule. Yeah? Okay, so let's look at x. X prime is 5, 2.5. And x was 2, 1. W prime, excuse me, is 0, negative 2.5. The original W was 0, 1. Y. Now a question is, you're probably thinking, well, how do you know that that's 2.5 and not 2.4 and not 2.7? Okay, we don't really know. So anyway, we're going to worry about that in a little bit. So y prime was negative 2.50. That's a point. And the original y was negative 1, 0. Okay. Now we want to grab our best set of matching coordinates. Okay, corresponding. So we want to grab our best set of corresponding coordinates. Okay, I'm going to grab these. Now, in that set of coordinates, one of them is the best. So I think I can get the rule out of the x coordinate of x and the x coordinate of x prime. So I'm going to go x prime over x. Yeah, see what I'm doing? New over old. Now, if I look at the x coordinates, I get 5 over 2, which is 2.5. If I look at the y coordinates, I get 2.5 over 1, which is 2.5. So I had at least one pair of corresponding parts that both of them were integers and one of them was not a decimal. Yeah. And then you could see that 0 divided by 0. Okay, that doesn't help us. Negative. Oh, there's a typo here. That's a negative 1. Negative 2.5 divided by negative 1 is 2.5. Negative 2.5. See how it works for all of them? But one pair of corresponding parts is going to be the best one to give you the rule. So what is the rule? 2.5. Okay, and notice from black to blue, it got bigger. Okay, so this is, if we were in a classroom, I would say turn to your neighbor and ask, did that make sense to you? But you guys are on Zoom and you don't have neighbors. So how are we doing on that? Does that make sense? I listed out all my coordinates and I found a pair that was easy to make a ratio with. Yeah, we're good. Okay, that's probably the hardest thing for today. Now, the rest is review. Okay. Reflection across the line, y equals x. Or it doesn't say that it's a line, but anyway, reflection across y equals x. So my first question is, what does y equals x look like? Horizontal, vertical, diagonal? Yeah? Can anyone tell me?
I think it's diagonal.
Ah, ding, ding, ding. Thank you. Okay, let's go back to algebra 1. Y equals x is the same as y equals x plus 0. I have a y-intercept of 0 and a slope of 1 over 1. So it's this diagonal right here. Yeah, y-intercept of 0, slope of 1 over 1. Even if you don't remember your algebra 1, it's the diagonal line. That is the line y equals x. Okay, so now fold your paper on that line and it should appear over here somewhere. Yeah, so eyeballing it. Do we see that it's going to appear over there when I fold my paper along that line? Okay, so do I have it here? Yeah. Okay, we're going to look at the bottom and we're going to see our chart. Now, when you come in to take your exam for unit 1 for week 5 and week 9, I give you the chart. So reflect across the line y equals x. xy goes to yx. We're going to talk about what that means in a minute. So here's the rule. xy maps to yx. Okay, so the big question is, what happened? Okay, did the signs change? No, no signs are changing. The only thing that changes is the order. Yeah, the only thing that changes is the order. So if F is 3, 0, the new F, which we call F prime. Yeah, Zoomers, can you type it in, everybody? If the only thing I'm doing is changing the order, if F is 3, 0, thank you, F prime is going to be 0, 3, right? I'm not changing any signs, just the order. If E is 0, -3, changing the order, not changing any signs, E prime is going to be here was my okay. E prime, thank you, -3, 0. Changing the order, don't change any signs. G is 3, -4. So G prime is going to be, yeah, Zoomers? -4, 3. Okay, let's do this in this purple will be good. Okay, so I'm gonna go 0, 3, 0, 3, -3, 0, -4, 3. Okay, see how my estimate was a little off? There is the actual transformation, the actual reflection. Yeah. Okay, let's do another one. Now, the reason why these are coming up, awesome. The reason why these are coming up is I'm seeing people make some mistakes. Okay, some people are reflecting across the y-axis, some people are reflecting across the x-axis. We need to reflect across the line y equals x. So let's start by drawing the line y equals x, y-intercept of 0, slope of up 1 over 1. Okay. This is going to be interesting. Okay, let's write the coordinates. A is 0, -1. B is 1, 1. C is -3, 4, and D is -5, -1. Okay, make sure my coordinates are correct. I think they're correct. Okay, we look at the chart and we see that XY maps to YX. Change the order. Do not change the sign. Okay. Work ahead of me, please, and do the transformation. Yeah, we ready? So Zoomers, type in please, A prime, okay? XY maps to YX. Zoomers, can you type in what is A prime gonna be? Thank you. All right, they're coming in. Awesome. -1, 0. B prime. Huh. Ooh, 1, 1. Can you see that B and B prime are the same coordinate? Okay, C prime. Thank you. 4, -3, and D prime. Thank you. Oh, wait, careful. There you go. -1, -5. Okay, so A prime is -1, 0. B prime is 1, 1. C prime is 4, -3. D prime is -1, -5. There we go. Now, when you reflect across the line y equals x, something looks a little off, but no, I think I'm good. It almost looks like a butterfly. Yeah, reflecting across reflections kind of create butterfly wings. So that's how to do that one. Okay, now you can skip. I think we have the idea of reflecting across the line y equals x. You don't have to do the number 7 unless you feel like you're still lost on these reflections. Request it and we'll do it at the end. It'll just be another example. Now let's reflect across the x-axis. Notice these instructions are different. So I'm going to highlight my x-axis. Okay, let's go ahead and look at the chart at the bottom of the page. Now, there's different ways to reflect across the x-axis. I'm going to use the chart. Some people would rather just do it visually, but I'm going to use the chart. So reflection across the x-axis. XY maps to x -y. Okay, so reflection across the x-axis. If I were to guess, I would guess it would look like this. Yeah, that's my guess. To write, yeah, go ahead and write these in on the packet. Would be good. It's good to practice. I'm not sure if I answered your question. Oh, okay. Oh, you don't have a packet yet. Okay. Now, so you can either, here's your options. you can either print it from Canvas. Okay, so you will find this in Canvas, Module 6, Tuesday. So today's not Tuesday, today's Thursday. Module 6, Thursday. Okay, and you will see it's called Toolkit. So I'm so glad you're here. Every Thursday at 9:30, we do the toolkit together. Okay, I have packets here at CTech. I can send it to Mount Vernon. Or so you can either print it at home or you can take the PDF and put it into Kami, Kami, and do it that way. Okay, so you are welcome. Okay, let's do our transformation. So D is 0, -3. No, sorry. D is -3, 0. Yeah, so D prime. Okay, Zoomers, do not change the order. Change the sign of the Y coordinate, the second number. Yeah, so -3 stays, 0. There is no -0. 0 is neutral. So there's D prime. C, -4, -5. Okay, there we go. Thank you. Anyone else? Don't look. What is C prime? The rule says change the sign of the second one. Don't change the order. So the first one stays. The second one changes to positive. And then E, 0, -4. Okay, Zoomers, what is E prime going to be? All right, thank you. 0, +4. Don't change the order. Change the sign of the second one. So now we're going to graph them. -3, 0. -4, 5. And 0, 4. Okay, erase my messy approximation. There we go. Okay, let's move on. Angle addition postulate. Okay, so we need to know the importance of the letters of the angles. So this angle right here, yeah. Okay, I want you to think about how I'm going to name that angle. And up here, it tells us what the value is. So look at that angle. What order do I name that angle? And what value am I going to write in? Yeah, does anyone see it? Okay, let's see. H-I-R. See how I have to do that order? I have to trace the angle. H-I-R. So then H-I-R, okay, what's the value of H-I-R?
36 degrees.
All right, thank you. 36 degrees. Okay, see how I did that? I traced H-I-R. I found it up here, and then I wrote it in. Okay, how about this one? Okay, so what am I going to call that angle? And what value am I going to write in? Oh, it is obtuse. True. But what I am looking for is letter names. Okay. So I'm going to call it RIJ, or I could call it JIR. Those are the only two correct ones. Or I could call it angle I. Well, not really, because angle I could be here or here. Okay. So I'm going to call it either RIJ or JIR, but I see that it's that one right there. Yeah, are you with me? RIJ. So I'm going to write 13x plus 10. Now, ooh, does this look like it's 180? I don't know. Looks like it, but it doesn't really say it looks like it's less than 180. Okay, so what am I going to call this one? Using letters. What am I going to call that one? HIJ. Yeah, thank you. Yeah, does everyone see that it's HIJ? So now this right there is 17x plus 6. Okay, so this is the angle addition postulate. Yes, postulate. Where you add baby angle plus baby angle equals big daddy angle. Okay, baby angle. So now I need an equation. Something plus something equals something. Yeah, so we need to look at the geometric figure and write the equation. So we need to think, what is the big one? What is the total? So we're going to say part plus part equals whole. Yeah. So does everyone see an equation? What am I going to put on this side? What represents the whole thing? Good. All right. Okay. Write your equation. I'll be right back. Done? Okay. And then I still have to. So I think that's 90 out of 108. So I think that's I still have to. You feeling not too bad about it? Awesome. Okay, so will you do me a favor, shut this down, plug it in, and you will know it's your real score when I hand grade it and it goes into our main Canvas course. And you want to check in with Mrs. Lee? She would probably love it. Thank you. And tell her you just took the test. She'll be curious. Thank you so much. Okay, now, do we see the equation? So the whole is the 17x plus 6, right? Do we see that the picture, perfect, thank you. The picture tells us that that goes over there. Does everybody see how I know that the 17x plus 6 goes over there? Yes or no? Could I have a yes or no? And you could do it in private. It can either be to everyone or direct message to me. Okay. Now, so I have a no. So RIJ, here it is right here. HIJ. So HIJ represents the whole thing. Yeah. So this is my part. It's hard to write. This is my part. And this is my whole. Okay. So if we still don't see it from the picture, we can talk about it. Ah, yeah. Is that better? Okay, good. Now, don't just go, oh, 17 is bigger. That could be misleading. Okay, so we don't know that because there's two parts being added together. So we have 36 plus 13x plus 10 equals the 17x plus 6. Okay, good. So we're getting it from the picture. Yeah. So 36 plus 13x plus 10 is equal to 17x plus 6. Okay, so now we're going to solve my equation. What should we do first? Combine like terms. Yeah, so let's add the 36 and the 10. So I'm going to start with my variable 13x plus 46 is equal to 17x plus 6. So now we're moving on to isolating my variable. So this is where some things start going left or right. Okay, so we need to decide who is going to be the king. So what variable do we want to lock into place? Which variable do we want to be the king? And then that's going to determine. So we're going to choose either the 13x because we like it because it's on the left, or the 17x because we like it because it's the bigger, more powerful one. So someone pick a variable to be the king, and that's going to lock into place. Okay, we have a vote for the 17x. The 17x is the king. So now the king is like, hey, you, get out of my room. We subtract 6x. Sorry, just 6, no x. Lining up like terms. Okay, so that leaves us 17x and 13x plus 40. Okay, the magic of OneNote. I needed a little more space. Okay, who is on the wrong side? Who needs to move? All right, so we're going to subtract 13x. Thank you. 40 is equal to 4x. And very often the last step is divide. So x is equal to 10. Now there's a trick. Sometimes, like for this one, the answer is not 10. We have to go back and we have to read the question. Okay, the answer is not 10. Find the measure of Rij. So Rij, okay, so I find the measure of angle Rij. Yeah, you with me? So I'm going to take, there's a lot of circling and highlighting here. So I'm going to take 13x plus 10. That, okay, I was given, that was the measure. And I'm going to plug in 10. Which is 130 plus 10, which is 140. That is the final answer. X equals 10, but it asked, what is the measure of Rij? The measure of Rij is 140 degrees. Okay, angle addition postulate. It looks really difficult at the beginning, but then the more you practice, if you can solve these equations, writing them becomes not too bad. Okay, we are going to move on. And guess what, team? They're going to start to get a little bit simpler. Okay, now we are going to practice. It says just find the measure. We are also practicing new vocabulary. Okay, now this is kind of embarrassing, but hello. Okay, now look at number 10. Now you're going to see this lovely glove I'm wearing because I'm writing on my Surface Pro. Anyway, and I can't believe this is going on the video. Anyway, okay, look at number 10. We see an angle, yeah, that looks like a right angle. Okay, it is a right angle. It looks like, I'm gonna get out. It looks like I'm about to shake hands. Yeah? So, can you see that that angle looks like I'm about to shake hands? Okay, I'm going to disappear now. Okay, so if I'm about to shake hands, I'm going to say, hey, see, like if we were in like traditional class, I would have you guys shake hands with each other. So I look like I'm about to shake hands. I make a 90-degree angle with my thumb and I compliment someone. Yeah, oh, you look really nice today. That reminds me that when I see a 90-degree angle with my thumb, those are complementary angles. So you may have heard geometry is not just about solving problems. The vocabulary is important. That's a hand, by the way. It looks horrible, but you can tell the thumb. Complementary angles. When you see 90 degrees, hold out your hand, put out your thumb, and think. Complement. Yeah, complementary angles. Now, complementary angles, yeah, their sum is 90 degrees. Okay, so how are we going to find B? Yeah, so what does that mean for the measure of angle B? All right, so we're going to take 90. So I'm showing my work. You don't have to show all that part right here, but showing my work is 90 minus 40 is 50 degrees. Okay, so all it asks was find the measure. But in the future, we're also going to have to start justifying with the vocabulary. Yeah, easy peasy. Next. Okay, picture me. I'm standing right here. Okay, my arms are out, welcoming you to my classroom. I have very long arms. And I'm saying, hello, what's up? I have a student here working on advanced algebra. He's like, okay, this is kind of weird. Anyway, what's up? Yeah, do you see me greeting you coming into my room? What's up? When my arms make, how many degrees is this right here? If my arms are completely flat, a straight line, aha, 180, right? If I say, what's up? I'm making a 180-degree angle. So supplementary angles, or two angles whose sum is, I could tell I was about to make an N there, huh? Whose sum is 180. Yeah, supplementary. So the question only asked for the number, but we're starting to practice with the vocabulary. So I'm going to take 180, I'm going to subtract 143, and I'm going to get 37 degrees. Yeah? Okay. Complementary, 90 degrees. Supplementary, 180 degrees. Now, sometimes it looks a little more complicated. Yeah, but we are basically ignoring this. This is just extra. Okay, team. Complementary, complementary, or supplementary? What do we have here? Complementary. You look very nice today. I'm about to shake your hand. That's right. That's right. Anyone else, Zoomers? Yeah, this is good for your brain. I don't ask it. Yeah, I ask it because it's better for your brain to participate. Okay, what's up? And supplementary angles equal 180. So 180 minus 120 is 60 degrees. Yeah, not too bad. What's up? What's up, Zoomer? What's up, Zoomers? Okay. This one, supplementary again. Yeah, see how it just got angled? 180 minus 113 is, I'm not really great at like subtracting when it involves borrowing. I have mine 280D. 67 degrees. And I'm lazy. Yeah? Okay, we're gonna rush on that one. If you want to see that slower. Okay, there's something else. Now, I'm gonna get rid of this. Because we're not looking at the triangles. Yeah? Okay. What letter do you see in this picture? I see the letter. Oh, you see an X. I asked the wrong question. Of course you see an X. Okay. What happens when I highlight this? I should have done that before I asked. If I highlight it, I have a blue one and I have a green one. Okay. Now that I've highlighted, instead of an X, I see two what letters? Boy, I'm not doing a great job asking this question. You see the letter V. I'm just going to tell you. It's a stretch. Okay. Now, this is really embarrassing, but okay. See my V's? Yeah. When you see this, you need to think V's. I know it looks like an X, but I need you to see two V's. Okay. This is the first year I actually started like turning on my camera to show you my little hand signal things. Okay, when you see these two V's, this one is from the blue V and this one's from the green V. These are vertical angles. Yeah, do you see why I need you to see the letter V? It looks like an X, but I need you to see V's. Vertical angles. And vertical angles are congruent, which means 3x plus 2 has an equal value to 56. Objects are congruent, numbers are equal. Yeah? Now, does that make sense that those are going to be equal to each other? Like if I did, let's take a look. If this is 40, does everyone see that this is 140? Yeah, supplementary. And if this is 140, does everyone see that that's 40? So see how supplementary angles give us that vertical angles are congruent. That was really fast and messy, but that's why it's true. Okay, so I have my equation. Vertical angles are congruent. I set them equal to each other and I solve. Okay, -2. And very often, the last step of solving the equation is divide. X is equal to 18. Okay. It is 10:30. Technically, we're done. If you need to go at 10:30, I'm going to keep going. We have 3 more problems that I'm going to do, but I understand if you need to leave. Okay. If you look at these 3 and go, okay, you know what? Number 15 is on your own. You could do that. Yeah. I'll just tell you. Can you tell that A is 90? B is complementary and B and C are vertical. We'll do that together if you want to stick around, but we need to do this one. So if I go all the way around the circle, B plus 38 plus 293 is equal to how much if I go all the way around the circle? Anyone feeling brave? Okay, fair. 360. Yeah, 360. Okay, let's combine like terms. B plus 331 is 360. Isolate your variable. What's my last step? We combine like terms. Isolate. All right, I'm going to subtract. B is equal to 29. There we go. Thank you. Okay. Yeah, moving on. I know you guys got to go. 17. Ooh, there's a typo. I don't know why, but there should be a box right there. That's 90 degrees. Oh, you know why? Because the question only asked for X. Can you tell I added that Y? Yeah, it's a little fuzzy. Okay. What letter do you see? There's a red one and a green one. You don't see the letter X. You see, thank you. You see the letter V. And when we think of V, we think of vertical angles. Vertical angles are congruent. Objects are congruent. Measures are equal. 2x is equal to 52. Divide by 2. X is equal to 26. Okay, if this is 90 degrees, wow, it looks like it may not be 90. I kind of transformed this equation. I mean, this picture. See how they're all 90? So if this side is 52, right? Vertical. How can we find y? $90 minus 52 is 38 degrees. Okay, 10:33. That is it. Unless you have requests, unless I skipped something and you want me to do. So thank you for coming. And new people, we have a couple new people. You are awesome. Thank you for coming. This is what we do. We meet every Thursday at 9:30 and I work through the toolkit with you. Okay. And I ask questions and you guys type in right or wrong. It's better for your brain to participate and type in answers. Okay. And that's what we do every Thursday. So some of them I said, do them on your own. Any questions? Anything you want me to do that I skipped, or are we done for the day? Are we good? All right. Thank you for coming. Okay. Bye-bye. Have a good week.